Hello everybody, this is Mika Seppälä. In this video I discuss the integration of polynomials involving sine and cosine functions. I will show how to integrate terms which are of the type sine to some power m times cosine to some other power n. There are many cases here. If n is odd, we have one method. If m is odd, we have another method. And if both m and n are even, then we still have to apply a third method. We then combine these three methods to integrate general trigonometric polynomials. The general problem that we will discuss here is how to integrate functions which are of the form sine to some power mx times cosine to some power nx. So to compute the integral of sine to the power mx cosine to the power nx dx, we use various methods. Let me first take a simple example. Consider the integral sine squared x times cosine x dx. This can be computed by the substitution t equals sine of x, because then dt is simply cosine of x dx. And we get the integral of sine squared of x cosine of x dx equals integral of t squared dt. But integral of t squared dt is just t cubed over 3 plus a constant of integration c. Return back to the original variable to get that the integral of sine squared of x times cosine of x dx equals sine cubed of x divided by 3 plus the constant of integration. This computation was possible since the function to be integrated was a simple polynomial in the sine function times the cosine function. But this idea can be generalized further. So we consider a general integral of the type sine to some positive integer power m x times cosine to some other positive integer power n x dx. And now if n is odd, then n is of the form 2 times k plus 1. And if that is the case, then we can rewrite the function to be integrated using the formula cosine to the power nx is now cosine to the power 2 times k plus 1 x, because n is 2 times k plus 1. And that can be written as cosine squared of x to the power k times cosine of x. This because cosine to the power 2k is same as cosine squared, and that raised to the power k, and then we still have to multiply this product with cosine of x to get cosine to the power 2 times k plus 1. Now cosine squared is 1 minus sine squared. Therefore, if n is odd and of the form 2 times k plus 1, then cosine to the power n of x can be written as 1 minus sine squared of x, and that raised to the power k times cosine of x. And if one performs this rewriting, integral of sine to the power mx times cosine to the power 2 times k plus 1 x dx becomes integral of sine to the power mx times 1 minus sine squared of x to the power k times cosine of x dx. And this last integral can be computed by the substitution t equals sine of x, because then dt is just cosine of x dx, and then the integration becomes to the integration of a polynomial in t. An example of this is the computation of the integral of sine squared of x times cosine cubed of x dx. Now the power of cosine is odd. And following the method shown just a moment ago, we rewrite sine squared times cosine cubed in the form sine squared times cosine cosine of x. And then we apply the formula cosine squared equals 1 minus sine squared, and we observe that the integral of sine squared of x times cosine cubed of x dx is simply the integral of sine squared of x times 1 minus sine squared of x, and that multiplied by cosine of x dx. Now we substitute t equals sine of x. When we do that, then dt equals cosine of x dx, and we get that the integral of sine squared times cosine cubed of x dx is simply integral of t squared times 1 minus t squared dt. This is integral of t squared minus t to the power 4 dt. This last integral is easy to compute. It is simply t cubed over 3 minus t to the power 5 over 5 plus the constant of integration. Returning back to the original variable, one gets that the integral of sine squared of x times cosine cubed of x dx is sine cubed of x divided by 3 minus sine to the power 5x divided by 5 plus the constant of integration. A similar trick can be applied if the power of sine is odd in the integral. So now we consider integrals of the type sine to some power m x times cosine to some other power n x dx, where m and n are positive integers. Furthermore, we assume that m is odd. Therefore, m is of the form 2 times k plus 1, where k is an integer. If m is 2 times k plus 1, then sine to the power m x is of course the same as sine to the power 2 times k plus 1 x, and this can be further rewritten as sine squared of x and that raised to the power k times sine of x. Sine squared of x raised to the power k is same as sine to the power 2 times k, and then we still have to multiply that by sine of x to get sine to the power 2 times k plus 1. So we observe that in this case sine to the power mx becomes just sine squared of x times to the power k times sine of x. And now sine squared is 1 minus cosine squared. Therefore, sine to the power mx becomes 1 minus cosine squared of x, and that raised to the power k times sine of x. We substitute this in place of sine to the power m in the integral to be computed. We get that the integral of sine to the power m x times cosine to the power n x dx equals the integral of 1 minus cosine squared of x and that raised to the power k times sine of x times cosine to the power n x dx. This can be computed by the substitution t equals cosine of x. Because if t is cosine of x, then dt is a negative sine of x dx, and the function to be integrated contains minus dt. It contains the factor sine of x times dx. Therefore, this substitution, t equals cosine of x dx, reduces this integral to an integral of a polynomial. We use this method to compute integral of sine to the power 7 x dx. In this case, the power of cosine is 0, but the same method still applies. So we compute integral of sine to the power 7 dx by observing that sine to the power 7 is sine to the power 6 times sine. And sine to the power 6 is sine squared and that raised to the power 3. So integral of sine to the power 7 x dx becomes integral of sine squared of x raised to the power 3 times sine of x dx. Now sine squared is 1 minus cosine squared. So this integral of sine to the power 7 x dx becomes integral of 1 minus cosine squared of x, and that difference raised to the power 3 times sine of x dx. Now we substitute t equals cosine of x. Then dt is negative sine of x dx, and we get that integral of sine to the power 7 x dx is just negative integral 1 minus t squared and that raised to the power 3 dt. Now 1 minus t squared raised to the power 3 is 1 minus 3 times t squared plus 3 times t to the 4th minus t to the power 6. So we have rewritten the integral to an integral of a polynomial in t. This integral is easy to compute. We get that the integral of sine to the power 7 x dx is, after substitution back to the original variable, negative cosine of x plus cosine cubed of x minus 3 over 5 cosine to the power 5 of x plus 3 over 7 times cosine to the power 7 of x plus the constant of integration c. Now if both powers of sine and cosine are even, then we cannot apply the previous methods. We have to do something else. So we now consider the integral of sine to the power m x times cosine to the power n x dx, and we assume that both m and n are even. Then we use the trigonometric formula sine squared of x equals 1 minus cosine 2x divided by 2, and cosine squared of x equals 1 plus cosine of 2 times x divided by 2. And furthermore, the formula sine of x times cosine of x equals sine of 2 times x divided by 2. And we use these formulae to simplify the function to be integrated. An example of this situation is the computation of the integral of sine squared x times cosine squared of x dx. Here now the powers of sine and cosine are both even. They are both 2. So the solution is that we rewrite sine squared and cosine squared in terms of cosine 2 times x. Sine squared is 1 minus cosine 2 times x divided by 2, and cosine squared is 1 plus cosine 2 times x divided by 2. Therefore, integral of sine squared times cosine squared of x dx is 1/4 times the integral of 1 minus cosine 2 times x, and this difference multiplied by the sum 1 plus cosine 2 times x dx. Now 1 minus cosine 2 times x times 1 plus cosine 2 times x equals, of course, 1 minus cosine squared 2 times x. So we observe that integral of sine squared of x times cosine squared of x dx is just 1/4 of the integral of 1 minus cosine squared at 2 times x dx. Now we still have to deal with cosine squared of 2 times x, and now we use the same formula again. We express this in terms of cosine 4 times x. That is cosine 2 times x. So this integral 1/4 integral 1 minus cosine squared 2 times x dx becomes 1/4 of integral of 1 minus 1 plus cosine 4 times x divided by 2 dx. This is, of course, the same as 1/8 of integral 1 minus cosine at 4x dx. And this can be easily computed. It amounts to x divided by 8. That is the integral of 1 dx, and that divided by 8, minus sine 4 times x divided by 32 plus the constant of integration c. The preceding methods can be applied to compute the integral of any function which is of the form p at cosine of x sine of x dx, where p is a polynomial in 2 variables. And this follows since if p is a polynomial in 2 variables, then p at cosine of x sine of x is a combination of terms of the form a sub mn times sine to the power mx times cosine to the power nx for some integers m and n. Hence, the integral of the function p at cosine of x sine of x dx can be computed using the previous methods. We integrate each term using one of these 3 methods just introduced. And in that way, we can compute any integral of this type.